Sensors let a machine sense the world. Actuators let it act on the world. A sensor tells the controller a tank is full, or a part has arrived, or a motor is too hot. But sensing changes nothing on its own. Something has to open the valve, push the cylinder, or turn the shaft. That something is the actuator. It is the muscle of automation, the part that turns a decision into motion. In this video, I will explain what an actuator actually is, then the three big families you will meet on any plant, linear versus rotary motion, and exactly how a PLC drives one. Let's start with the idea. Quick note before we dig in. This is from PLC Simulator, where you can practice motion and automation, and the rest of this video, free, right in your browser. No install, no hardware. The link is in the description. Click the link in the description to try it free. Now back to the muscle. So what is an actuator, really? An actuator is a device that converts energy into motion to move part of process. That is the whole job. It takes energy, compressed air, hydraulic fluid, or electricity, and turns it into a push, a pull, or a turn. Think of the split this way. The sensor measures. The actuator acts. A controller, usually a PLC, sits in the middle. It reads the sensors, decides what to do, then commands the actuators. Without sensors, the machine is blind. Without actuators, it is paralyzed. You need both. And almost everything that moves on a plant is being driven by an actuator. A valve, a cylinder, a conveyor, a damper, a robot joint, all of them. Actuators come in three big families, split by the energy they use. First, pneumatic. These run on compressed air. They're fast, cheap, simple, and clean, which is why air cylinders are everywhere in packaging and assembly. The trade-off is that air is springy, so precise positioning is hard. Second, hydraulic. These run on pressurized oil. Oil does not compress, so hydraulics deliver enormous force in a small package. Think presses, heavy lifts, and injection molding. The trade-off is leaks, plumbing, and a noisy power pack. Third, electric. These use motors, servos, steppers, and plain motors driving screws or belts. Electric actuators are the precise ones. A servo can hit a position to a fraction of a millimeter and hold it. I cover servos in detail in the linked What is a Servo Motor video. Air for speed, oil for force, electric for precision. There is a second way to split actuators, by the shape of the motion. Linear actuators produce straight-line motion. A pneumatic cylinder extending and retracting is the classic example. They push, clamp, lift, and eject. Rotary actuators produce turning motion. An electric motor is the obvious one, but you also get rotary air actuators that swing a quarter turn to open and close a valve. And that brings up the actuator you will meet most in process plants, the control valve. A control valve is an actuator bolted to a valve body. The PLC sends a signal. The actuator strokes the valve open or closed, and that regulates flow, pressure, level, or temperature. On a process line, the control valve is the hands of the system. Now, the part that matters for programming. How does a PLC actually drive an actuator? It comes down to the kind of output. For a simple on-off actuator, the PLC uses a digital output. It energizes a coil. That coil switches a solenoid valve, and the air or oil shoots to the cylinder. One bit, on or off, and the cylinder moves. For an actuator that needs to be positioned anywhere in a range, the PLC uses an analog output. It sends a signal, classically 4 to 20 milliamps, to a control valve or a variable speed drive. 0%, 50%, 100%, anything in between. So the rule of thumb is simple. On-off actuator, digital output, and a solenoid. Proportional actuator, analog output to a valve or a drive. Get that mapping right, and the rest is just logic. So here's what to walk away with. An actuator converts energy into motion. It is the muscle that acts on what the sensors sense. There are three families: pneumatic for speed, hydraulic for force, electric for precision. Motion is either linear or rotary, and the control valve is the classic process actuator. And a PLC drives them with digital outputs for on-off and analog outputs for anything in between. Get that, and every moving thing on the plant stops being a mystery. Now, to go make it concrete. If you want to practice automation and motion hands-on, click the link in the description to start free at plcsimulationsoftware.com. No hardware, no install. Subscribe. New video every Tuesday. See you in the next one.